All right, we're going to be solving 32 exponential and logarithmic equations today. 8, 8, 8, and 8. Fun times. These are not hard questions, though. We just need to approach them very methodically. They all have very simple approaches. The thing that we need to remember about all of these is that when you deal with these, remember a logarithm and an exponential function, and I'll make those words bigger in a second, are inverses. And if you remember this, that basically does most of the solving for you. Remember, of course, that this means that to get rid of a logarithm, you use an exponential. And to get rid of an exponential, you use a log. In both cases, you use the same base. And everything else that you do in these problems is going to be just basic Algebra 1 stuff of take away the stuff that's in the way of x being by itself. And that's all it is. The only other detail we have to remember, well, I guess two things. We do need to remember our log properties for a few of these. Not too many, but there's a few where we have to remember the log properties. And we have to remember that you cannot plug a negative into a logarithm. Okay, this is all the detail that we are going to get into as far as what you need to know to do these questions, and that's it. And these are things that hopefully you've seen already, that you've been going over with various other sheets that you've seen time and time again. I've recorded several videos here, so these are things that should be comfortable, all of them by now. The only one that might not be completely comfortable is the log properties, because sometimes they're a pain in the butt to remember. But beyond that, this should be pretty straightforward. So we're going to hop back over to sheet number 1 here, and we're going to notice that these are exponentials that we have to solve using logarithms. So all we're going to do is we're going to apply a log to both sides. So I'm going to write log 3. Okay, I need a smaller font size now. I'm going to write log 3. That's my way of writing with the inline text, just log base 3. That does not mean you write a 3 after the log. Log 3 of 3 to the x is equal to log 3 of 18. Okay, that looks weird with the space there. We're just going to do log base 3 on both sides, and then the log base 3 cancels out with the 3 to the, and the left side just becomes x, and the right side becomes whatever log base 3 of 18 is. You're going to use a calculator to figure that out. I'm just going to go through the solution, so you'll have to push the buttons to find out what those numbers are, but that's the idea, is it's just one simple step and then a reduction. So in number 2, the base of our exponent is a 7. Therefore, we're going to apply log 7 to both sides. 7 to the y equals log 7 of 24. Therefore, when we cancel, we get y equals, and then whatever log base 7 of 24 is. Number 3, there will be an additional step because we've got that minus 3 up there, but we start off by saying we need to get rid of the 12 to the. 12 to the is an exponential. We'll use a log to get rid of it. And it's base 12 exponents, so base 12 logarithm. Okay, and I guess technically, if I want to write this correctly, I have to put parentheses around the n minus 3. But I assume you knew what I meant there. All right, log base 12 of 12 to the cancels. We're left with n minus 3 is equal to log base 12 of 60. 2 to the 3a equals 142. All right, so we'll do log base 2 on both sides. We cancel, we get 3a equals log base 2 of 142. 15 to the, all right, so we'll undo with a log base 15. Now, another way that you can sometimes think of what we're doing here is to say that this is written in exponential form and we need to rewrite it in logarithmic form. I know that's the way that a lot of teachers will present this, is that they will say, oh, we'll just shift it into logarithmic form. And my response to that, oh, it occurs to me I should probably do the last step on these, huh? log 12 of 60 plus 3. The way I think that you should go about trying to write things from exponential to logarithmic form is by doing exactly what we're doing, though. $87 plus 5, 3, and then I need to get a line here. Boom. Oh, wait a minute. My parentheses are in the wrong place. There we go. All right, so that should take care of like all the steps there, right? You would probably at this point, whatever log base 15 of 87 is, go to your calculator and figure that out. So I'm going to put a couple things in pink boxes here to just say this is the point where you use the calculator. So when you hit that point, plug that into the calculator and figure out what it is. But since I'm not going through that, I'm just going to keep going with whatever the heck that value is, and you can do the rest from there. All right, so very straightforward. Therefore, we'll do log 4 on both sides here. Hopefully by now you can get the pattern. You can probably pause the video and just do it yourself at this point. Over 8 and line there. Okay. This last one we'll have to divide by 4 first, so 10 to the k is equal to 15. Now we have the exponential by itself. So now we can do log of 10 to the k equals log of 15. I don't even have to write a number under there because it's base 10. So k is equal to log of 15. 16 to the n is equal to 51. Log 16 of 16 to the n is equal to log 16 of 51. So that is just what n equals. So the difference I want to point out between questions 3, 4, and 5 and 6, and then questions 7 and 8, is that with 3, 4, 5, and 6, the extra step that we had to do is inside the exponential, right? If you were talking about what number do I need to get rid of first in number 12 to solve this, you can go, oh, well, the thing that is most immediate that we need to strip away is this 12, and then we'll get rid of the minus 3 afterwards. In this one, we go, oh, we need to get rid of the 2 to the, then we'll get rid of the times 3. With number 6, get rid of the 4 to the, then the minus 2, and then the times 8. But not with number 7. With number 7, the 4 is the first thing we want to get rid of because it's outside. It's the thing farthest from the variable, so it's the thing that we're going to take away first. Likewise, with number 8, the minus 6 is much farther from the n than the 16 to the. So this should give you an idea of how this page goes. Now let's scroll down and notice that we've got a whole bunch more where the steps are going to be a little more complicated. Now I'm going to go through these a little faster. So I'm going to basically not do every last step, but I am going to give you the most important parts, which is we're going to get rid of the 9 first because it's the thing that is farthest away. So we add 9 to both sides. Then we're going to need to do a log on both sides to get rid of the 13 to the. I'm not going to write all that out. It takes a while, but this is going to be log base 13 of 26 on the right versus c minus 8. And now we got to get rid of the 8. So 8 plus the same stuff from before. 10. So the first number we need to get rid of is the 2. So 8 to the 5r is equal to 14. Then we will do a log 8 on both sides. And we will get 5r equals log 8 of 14. And then r is equal to 1/5 times whatever we had before. Number 10, the first thing we need to get rid of is the plus 3. So 10 to the 2x minus 7 is equal to 60. Then we need to get rid of the 10 to this. We're going to do log on both sides, common log, that is. 2x minus 7 is equal to log of 60. And then we will say x is, we will add 7 to both sides. And then we will divide by 2. For number 12, we will subtract 6. So we will have 8 to the 6 minus 4x is equal to 16. Then we will do log 8 on both sides, and we will get 6 minus 4x is equal to log base 8 of 16. We will subtract 6. So negative 4x equals log 8 of 16 minus 6. And then we will divide by negative 4. So probably the best way to write that is to change the signs around here. And also to, oh wait, I can't reduce that because there's no coefficient on the logarithm, right? Besides, why do I care to reduce it if you're just going to plug the log base 8 of 16 into the calculator? Am I right? Am I right? Of course, that's exactly what you're going to do. Okay, so let's think about this one. 6 times 4 to the m, the thing that's farthest away from the variable, the thing that you would do last if you were substituting in a value for m, would be the minus 14. So we're going to get rid of the minus 14 first. Then we'll divide by 6 because that's the next thing farthest away. 102 over 6 I don't believe is an even number. Right, it's 96 is, oh wait, no, 102 does come out evenly. I'm sorry, it's 17. And then log base 4 of both sides. And so this just becomes m equals that stuff. All right, 9 times 12 to the r plus 4 is equal to 135 because we got rid of the 8. Then get rid of the 9. R plus 4 is equal to 135 over 9, I believe is 15. Then we'll log 12 both sides. And we'll get r plus 4 is equal to log 12 of 15. So obviously we'll need to then subtract 4. All right, starting to run out of space down here. I'm going to come up here for this. Negative 5 times 4 to the 6x is equal to, we'll subtract 5. Okay, now these negatives are a little scary at first, but when we divide by negative 5, it straightens itself out, so we're cool, All right, so log 4 both sides, we get 6x equals log 4 of 7, and therefore x is equal to log 4 of 7 divided by 6. Move that slight bit down so it doesn't blur over the line. Okay, excuse me. All right, all kinds of steps in 16, but let's think about it logically, okay? So if you weren't following the idea of how I was picking the order, let's talk about this in detail with this one. So the way that I think of solving an algebra equation, if we were to talk about something like, for instance, 6 parentheses 7x plus 2 equals 13. What I would do is I'd say, what is the number that is closest to the x? What number is farthest, using order of operations? Or put another way, if we didn't know what this is and we just went, oh, but x is equal to 3, let's figure out what this is. The first thing you would do is you'd say, oh, times 7. Then you would do, oh, that plus 2, and then whatever that is, you do times 6. And so when we solve equations, we strip that away in reverse order. We peel it away, outermost layer at a time. So in this case, the outermost layer is the times 6. Then we have the plus 2, and then we have the times 7. And so if we were to go and try to solve this, we'd say 7x plus 2 is equal to 13 over 6. Then we would say 7x is equal to 13 over 6 minus 2, which, if we want to be fancy about it, using common denominators, that's 1/6. And then we would get rid of the times 7 by dividing by 7 and get 1 over 42. And we're going to use the same exact idea here with this messy, complicated expression. We're going to say, okay, so if we knew what p was, instead of having a 194 over here, if we knew what p was, let's just say p is 1 for the sake of argument. So the first thing we would have done is we would have done times 3. We've done like 1 times 3 is 3. Then we would have said whatever that is, we would then do the minus 9. Then order of operations tells us we need to do exponents before we do anything else. I'll put blank here. Blank times 3, blank minus 9, 11 to the blank. Then we would do 8 times whatever that blank is. And then finally, we're going to do blank plus 10. That would be the order we would do things going in the forward direction. So in order to solve this, we got to go in the backwards direction. So we're going to start off by getting rid of the plus 10. So we have 8 times 11 to the 3p minus 9 is equal to, we subtract 10, 184. And then we get rid of the 8 times. So we'll divide by 8. 11 to the 3p minus 9 is equal to 184 divided by 8. Can I do that in my head? That's 160 plus 24, 23. Okay. Then we're going to get rid of the 11 to the by using log base 11. And I have dogs barking outside now. Hi, neighbors. I don't know if you can hear that. All right, then we'll simplify that. 3p minus 9 is equal to log 11 of 23. And you know what? This time I will grab a calculator. I will grab a calculator and figure out what that is. That is log 23 over log 11, because I have to use change of base on my old calculator. And that is equal to 1.308. I don't know how many decimal places your teacher requires, but I'm going to do 3. So then 3p is equal to that plus 9, so 10.308. And then p is equal to, oh, I shouldn't have hit clear, 10.308 divided by 3 is 3.436. So that's going to be our general strategy for solving all of these questions. Hopefully that made sense. Now, that is one pair of worksheets. We are going to then hop over to number 2. And in this, now we have some logarithms to deal with. Not entirely. If we come down here, there's more exponentials down below. So maybe we should do those first. But we do have some logarithms up top. So while we're doing exponentials, let's just continue on with the exponential, shall we? I think this makes more sense to continue here. So I'm going to do this bottom part first, where we have more exponentials. So we've got 25 to the stuff equals 625. We need to get rid of that 25 to the. How do we do that? Log base 25. There is an alternative with this particular question because 625 is a power of 25. So you could do this a second way. But if we're going to be talking about consistent methods, we'll just do this over and over again. So v minus 2 is equal to, and log base 25 of 625 is 2. I can do that one in my head because it's 25 squared. All right, so that means v equals 4. For number 10, we need to get that variable down from the exponent, which means we need to get rid of the 8 to the. So we're going to do log base 8 on both sides of 8 to the stuff. And that should be in parentheses, the 4x minus 2. I'm being lazy. All right, log base 8 of 1/16 is negative 4/3. And the other side is 4x minus 2. So now we'll add 2 to both sides. So that's 6/3 we're adding to both sides. All right, so 2/3 is equal to 4x. And so divide by 4, we get 2/12, or 1/6 is equal to x. Pretty sure, unless I screwed that up. But I think that's how it goes. All right, 11, there's nothing fancy. 11's the easiest question on this sheet. We're just going to say log base 8 on both sides. Log 8 on both sides. And so k is equal to log base 8 of 78, which does not come out evenly, so I don't know that one in my head. Similarly, we'll do log base 9 on both sides for this. So we get m minus 6 is equal to log base 9 of 78. So m is equal to whatever that number is, plus 6. But now we get down to slightly more complicated ones where we got extra steps. All right, so 15 to the 3a is equal to 60 because we're going to subtract the 7 first. Then we'll do a log 15 on both sides. We'll get 3a is equal to log 15 of 60. And then a is equal to 1/3 of that, or that divided by 3, or however you want to think of it. 14. We'll subtract 9 from both sides. So 14 to the stuff is equal to 77 minus 9 is 68. Then we'll do a log 14 on both sides, and we'll get 3 minus 8x is equal to log base 14 of 68. And then we will need to say subtract 3. And then we will need to divide by -8. So for fun, I'll actually figure this one out. Log base 14 of 68 is 1.773. If I subtract 3 and then I divide by -8, I get 0.153. Now, one thing I have been overlooking here is that if you go through and figure out what these are, you have to make sure you're not putting a negative into the logarithm. But I don't think in these cases, with the direction we're going, that's an issue. I think it's only going to be an issue with the number 1 to 8 of this particular sheet. So I think we're probably fine to not check that. All right, 8 to the times 3 to the n minus 1. We'll add 21 to both sides. We'll divide by 8. Okay, so we'll do log base 3 on both sides, which is going to give us n minus 1 equals 2. So it means n equals 3. Let's check it, actually. Let's think about this. If we put a 3 here, right? If we did a 3, 3 to the 3 minus 1 is 3 squared, which is 9. So we have 8 times 9 minus 21. 8 times 9 is 72. 72 minus 21 is 51. Yes, it worked. Okay, good stuff. So if you need to check your answers, that's how you're going to do it. Even if it means you have to plug some really awkward number into a calculator. Hey, whatever, you use the calculator, don't worry about it. All right, 2 times 18 to the 10r minus 3 is equal to 74. Then we'll divide 18 to the 10r minus 3 is equal to 37. And we'll log 18 both sides. Then we will say 10r minus 3 is equal to log 18 of 37. And we should probably say, what is that number? Log 37 divided by log of 18. Okay, I got about 1.25. So I'm just gonna say is about 1.25. So therefore 10r is equal to 4.25. And dividing by 10 is nice and easy. We just shift a decimal place. This is 0.425-ish. You might get a slightly different number from rounding. All right. So there is all of our exponential equation questions. Now let's talk about some logs real quick. So logs are slightly more arduous, but also at the same time kind of not, because you might not need a calculator to do them. You might be able to just say, oh, well, let me do the exponential on both sides, and you can figure that out sometimes. But we do have to make sure we're not plugging in a negative, and that's the important part. So, all right, for number 1, we have a log on both sides. Our goal, in general, will be to exponentiate both sides so we can clear the log. If there are logs on both sides, then we need to have just a single log and make sure the bases match. If there is not a log on both sides, well, then we're going to end up with creating an exponential on the other side, but that's okay. We'll see what that looks like when we get to 5, 6, 7, 8. But we do need to simplify these sides to having a single logarithm or a single expression, a single term on both sides. Now, it's not an issue with number 1. There is a single term. There's a log 7 of stuff equals a log 7 of stuff. So we don't got to do anything fancy. We just got to say 7 to the this stuff is equal to 7 to the that stuff. And what's going to happen is the 7 to the and the log base 7 will cancel. And we're left with 9x minus 4 is equal to x plus 20. And now we just solve normally. And we get x equals 3. Now, quick check. If we plug in a 3, 27 minus 4 is 23. 3 plus 20 is 23. We have the same thing on both sides. Both sides are log base 7 of 23, whatever that is. And we don't care what it is. We just care that it's the same. So that checks out. All right, number 2, we got a log base 5 on both sides. To undo a logarithm, we use an exponential. The base of the logarithm is 5. So the base of the exponential will be 5 to the. So 5 to the stuff equals 5 to the stuff. And I'm being lazy and not writing it. Of course, you should write that on your paper, but then that'll simplify to m squared minus 12 is equal to m. Now that's a quadratic. So to solve a quadratic, we're going to bring stuff to one side, set everything equal to 0, and then factor. And we need numbers that multiply to negative 12 and add to negative 1, which should be a negative 4 and a positive 3. So m equals 4 or negative 3, but let's hold on now. Can we put a 4 in? Well, 4 is 4 squared 16 minus 12, which is 4, is equal to 4. Okay, so log of 4 equals log of 4. That checks out. But if we put in on negative 3, over here, negative 3 squared is 9 minus 12 is negative 3. And log over here is negative 3. It's the same thing, but what did we promise? We said you cannot put a negative into a logarithm. So that does not work. Now, the fact that this number itself was negative is not important. What matters is that after you plugged it in, it was negative, right? Like we put the negative 3 here, and it gave us 9 minus 12. So far, okay, until we do the subtraction and we get a negative. And because this is negative, that's where it's no bueno. Over here, the number we plug in is the inside of the logarithm, so they end up being the same thing. But if it had been a more complicated expression, you can use a variable value that is negative as long as it doesn't make the guts of the logarithm negative. So it is possible that something like that could happen. I have seen questions where that is the case. I don't think that's going to happen on this worksheet, but it can happen. All right, number 3. 3, we don't have a single log. We have 2 logs. And so to combine them, we're going to need to use our log properties. Now remember that when you have addition on the outside, that's like saying do multiplication on the inside. So this becomes 4 times a plus 5 is equal to log 3 of 56. So we simplify that to 4a plus 20 is equal to log 3 of 56. And now we're going to do 3 to the on both sides. We're going to get 4a plus 20 is equal to 56. Because once we have just a log on both sides, the 3 to the on both sides business works, and it will cancel nicely. And now we simplify and solve. Ta-da. Okay, number 4, the left side is simple enough, but the right side is awkward. So we actually have to use 2 log properties. We first have to bring the 7 inside using the power property and saying that this is equal to log of 2 to the 7th minus log of 8. And if that weren't bad enough, then we have to use another log property, the subtraction to division rule, to say that this is equal to 2 to the 7th divided by 8. Which, by the way, if we're to simplify that to make our lives easier, that's equal to 16. Okay, now we're going to clear the logarithms by doing 10 to the on both sides. And we get 2y minus 10 is equal to 16. 2y is equal to 26, y is equal to 13. And I guess, just to be completely clear, what I mean by doing this process on both sides, what it's going to look like, let me just write it out. We're going to have 10 to the 2y minus 10 is equal to 10 to the, or log of, excuse me, I would help if I wrote this correctly, if I'm going to demonstrate it. So I need to go zoop, because I need a log here. Okay, and then what we're going to say is that the 10 to the and the log base 10 are going to cancel. And that's how we end up here. So this is what I mean by doing 10 to the on both sides. I'm using a very shorthand notation because I'm trying to do this in a way that doesn't involve a whole lot of writing with the mouse. But That's all we're going to do. All right, so number 5, now we don't have a log on the right side. Is that a problem? But we still need to get rid of the log on the left side to get the m by itself. So we need to strip away that log. It just so happens we don't have a log on the other side, but who cares? This is now basically just an Algebra 1 question. Peel away the layers. The layers in this case would be, first thing we would want to do is times 5, the second thing would be plus 9, and the third thing would be to do the log. So to peel away the layers, we do that in reverse. So we're going to get rid of the log base 4 by doing 4 to the is equal to 4 to the third. And of course, the left side will cancel and simplify to 5 plus 9 equals, and 4 to the third is just 64. Now it's really an Algebra 1 question. We'll subtract 9, and then we'll divide by 5 and get that. Hopefully that made sense. Because all we're doing, we want to reverse the order, right? So in number 6, we do times -4, then we'd add the 20 in, then we do the log. So let's peel that away. We're going to do 36 to the stuff is equal to 36 to the 1/2. So the stuff in this case that simplifies is 20 minus 4p. And 36 to the 1/2 is a fancy way of saying square root of 36. So that's 6. All right, let's kick that 20 out of there by subtracting, not 4p, not 4d, 4p is equal to -14. And so p is equal to 14 over 4, which is the same thing as 7/2. Does that work? Let's make sure that we did this correctly. I want to say 20 minus 4 times 7/2. All right, so 4 times 7/2 is 28 over 2, or 14. 20 minus 14 is 6. So we have log base 36 of 6 is equal to 1/2. Is that a true statement? Well, plug this into your calculator and find out. Yes, it is. Okay, so it checks out. All right, let's go down to the last two. All right, so what do we need to do first? Answer that to yourself before I start doing it. Outermost step is the log base 6. So we need to get rid of the log base 6 by doing 6 to the. 6 to the, everything that we had on the left side is equal to 6 to the third. When we cancel the 6 to the with the log base 6, we get 7k minus 1 is equal to, and then 6 to the third, 6 times 6 is 36, times another 6 is 216. All right, 7k is equal to 217. K is equal to, let's see, that's 210, which is a 30, plus 7, so another 1, so 31. All right, and none of these, by the way, look like they're giving us a negative if we plug in. Right, even here where we have a minus 10, we're still in the clear. So I think we're good. All right, number 8, though, we need a log property first before we can simplify this, because we need a single logarithm. So this is n plus 8 times 4 is equal to log, or not log, just 2. All right, and if we want to simplify that, we can say it's 4n plus 32 is equal to 2. Well, now we're going to do 10 to the log of 4n plus 32 is equal to 10 to the second. So 4n plus 32 equals 10 squared is 100. Subtract 32 is 68, and n equals 17. So log of 25 plus log of 4 equals 2. Plug the left side in your calculator and make sure, but yes, that's going to work out. So this is going to be your complete rundown of everything. Hopefully this all made sense to you. But this is a very elaborate and long review of solving equations involving exponents and logs.